In this lecture, we're going to talk about the quantities that can be measured. There are also quantities that cannot be measured, but in this video, we're going to just talk about the quantities that can be measured. It has two types, scalar and vector, and there's a minor difference between the scalar quantities and the vector quantities. Scalar quantities have certain number and a suitable unit. Just suppose 3 meter. Now it's a certain number and it is a suitable unit for it. We can also say 3 centimeter. It depends on the condition or it depends on the situation that what you're gonna use with this certain number. In vector quantities, it has certain number along with suitable unit and a particular direction is just told in the situation. Now just suppose 3 meters ahead. Now there's a particular direction that is just given and it tells that it's a vector. Now when we just include certain number or suitable unit along, we just say it's the magnitude of that quantity. Here also the magnitude is given but plus particular direction. Now there are some quantities that just describes the scalar or vector. First of all, length. Length is a scalar quantity because length does not describe the shortest path, or length is like, we can say that length like this, length like this, length like this, like it's just not a constant that what direction will length do. Here's the mass. Mass does not have any direction. It just have a certain number and a suitable unit. Time does not have any direction. Electric current does not have any direction. Thermodynamic temperature does not have any direction. Distance have direction, but the distance does not just says that, like, here's a point and it's a point. This distance, it does not have a particular direction. As also speed, like speed, it just took a distance like this, take a distance, the distance per time, like distance is multiplied by time, so it will give us the distance, and if the distance is divided by time, it just gives us the speed of that direction or that points. Heat does not have any direction, energy does not have any direction, charge does not have any direction, light air does not have any direction. Light air is a state, or it's a term that is given to the speed of the light in the universe or in the vacuum. Wavelength does not have any direction. The question is that this is the direction, but we cannot just give a certain or constant number, constant to value or direction that wave is moved in this direction. It cannot just move in any other direction. It can be moved in any direction. Wavelength just shows the wave. It's a property or it's a nature of the wave. So wave cannot be measured, so wavelength cannot also be measured. Frequency is just relatable to the wavelength, so it also cannot be measured. Amplitude is also in the family of the wave, so it is also not measured. Work is not measured. Power cannot be measured, it does not have any direction. Electric flux also don't have any direction. Electric flux is basically the passage of the electric current from a particle or from a surface. Entropy does not have any direction. Entropy is simply the reaction of anything. Entropy just shows the reaction. Like from the Newton's third law, every action has a reaction. Just entropy just work at like that. Pressure does not have any direction. Yes, we don't know where the force is being applied. Now let's come to the vectors. Displacement has direction. It's the particular direction or the shortest direction between two objects, 2 points. Velocity has direction because it divides the displacement by time. Acceleration is also divided. It also divides the displacement per delta time. Deceleration, it's the opposite. The acceleration. Force has a particular direction. Also, weight doesn't have a particular direction, just comes center of the gravity. It is just like gravity is included in weight, tension, as well as reaction. These three are from one family and it includes gravity in it. Linear momentum, we know that linear momentum and angular momentum are as it is, but the difference is that linear momentum just works like that and angular momentum works like that. So these two also have a particular direction, so we can say that it is vector quantity. Impulse, it also has a direction. It is like it is a fastest reaction of anything. Magnetic field also have direction. Sharing stress also have direction. So that's all about the vector and scalar laws. So now let's talk about the value of gravity. The value of gravity of different planets in meter per second and volts. The value of gravity of Pluto is 0.7, Earth is 9.8, Moon is 1.6, Mercury is 3.7, Mars is 3.7. Now there's a minor difference between the ratio of these two. These two are as it is, they are just like same, but the ratio is little bit different. Uranus has 8.7, Venus has 8.9, Saturn has 9, Neptune has 11, Jupiter has 23.1, Sun has 274. So the highest gravity rate is of Sun, and then Jupiter, and then Neptune, and then the Saturn, then Venus, then Uranus. These two are same. No, after Neptune, Earth has the like more gravity rate. After then Saturn, Venus, Uranus, Mercury, Mars, and after that Moon, Pluto. Now there's another topic that we're gonna talk about. We're gonna talk about the dot product and cross product. Now what are the products? Product just means multiplication. Just memorize that. Now in the physics there are products of vectors and scalars. So in the dot product, the product of vector or vector becomes a scalar. So we can say that it's a dot product of that object or that quantity. But in the cross product, vector into vector just gives out a vector. So we can say that it's a cross product. Now the dot product direction is always cos theta. And the direction of cross product is always sine theta. Now we're gonna just talk about the work. What is work? Force into displacement just means work. These two quantities are vector, but it gives out a scalar quantity. Work is a scalar quantity, but according to the formula, force into displacement, these two are vector quantities. Now we can say that dot product of force and displacement is equal to the work. Now, as I have told you, dot product has cos theta. So we're gonna just write that to F into D cos theta. Now, here's some condition. If the force is 0, the work will be 0. If the displacement is 0, the work will also 0. If the theta is 0, I'm talking about if there is no angle, the work will also become 0. Now here are some conditions of theta, of angle. Now suppose a person who is carrying a bag, it's a bag. Now he's applying the force upwards and he's covering displacement downwards. Now what will be the direction? It will become 90 degree. So we can just say that the angle occurred is 90 degree. Now it has constant weight. Like I'm just giving a situation. If the force is also 10 and the displacement is also 10, just let's put it. 10 into 10 cos 90. Now let's see what's cos 90. Cos 90 is equal to 0. So we can write that simply like it's 0. So we can write that 100 joule meter per second. So here's the first condition solved. Now what if the theta is 0? Like a person is walking straight, he's applying a force in the straight in the form of friction force and he's covering the displacement in the straight. So we can say that what's the direction? It's 0. So here's the condition that if theta is 0, the work covered will be maximum. So let's just apply 10 multiplied by 10 cos 0. Now let's see what's cos 0. Cos 0 is equal to 1. Now here I have done a mistake that multiplying 0 by anything will give us the 0. So the work will be 0. And by multiplying it by 1, we will get 100 joule. Sorry for that. What if the theta is 180? Like a person is covering displacement forward, but he is applying force just backward. So what will be the simply angle? Angle will be 180. So let's find out 10 into 10 cos 180 oh, minus 1. It's minus 1, so we answer will be minus 100 joule. So condition proved minus. Now What if the force applied is like this? Now just suppose the angle is 60. So what is cos 60? Let's see. Cos 60 is 0.5. 10 into 10. Cos 60 is 0.5. So let's just multiply it by 100. It's 50. 50 joule. The maximum is 100. If the degree is 90, it's 0. If the degree is 180, it will be negative. If the degree is 60, it will be half. And that's about whole lecture.